Hello there, Sven. How are you doing? Good afternoon.
Hi, Aditya. Pleased to be here.
Excellent. Sven, firstly, I wanted to thank you for being a part of this. As obviously everyone knows that we are in unprecedented times. We're all stuck at home in lockdown across the world. So I think we've discussed that this is probably the best time to, or a very good opportunity to talk about capacitance measurement as a technology and your experience with it. I have to say that you are one of the very first users and experts on capacitance technology. And I will let you introduce yourself as well, Sven. But our association goes back a long time. We know each other for a few years. We've interacted with each other at conferences, and I've come and visited you as well. So I think you are in a very unique position, Sven, because you're an expert on capacitance measurement and using this technology to, to measure the biomass in cell culture processes. But you're also an expert on viral vector manufacturing and vaccine manufacturing processes. So you can bring a very useful perspective that our listeners would appreciate. So yes, thank you so much for doing this, and I'm going to let you introduce yourself a little bit, Sven, for people who are not aware of or not familiar with your background.
Sure. Thank you, Aditya. And first of all, thank you very much for setting this up. I think this is it's a perfect time to do that. As you said, we're all stuck in home office, and it's not easy necessarily to get work done, in particular when you have kids at home.
That's right.
You know that very well. But no, I think this is great, and I also hope that there will be people out there who will be enjoying this conversation. So for those who don't know me, and this is, I would expect the large majority of the people who are watching this, thank you, first of all, for these compliments. But I was exposed to the technology a bit more than 15 years ago now. And then most of the work, and this was really by coincidence, most of the work that I did with the technology was at the National Research Council in Canada. I now moved away. I stay connected to the National Research Council, but I'm now working for a small cell therapy company. Unfortunately, we're not using any capacitance technology at the time. Right now, maybe later, who knows? Thank you for calling me an expert. I'm really not the only one, but I definitely have worked with different expression systems in process development settings. What I also would like to add is that I'm unbiased, I think, when it comes to which company makes these systems and probes. Yet I'm not unbiased when it comes to the technology itself. And I'll obviously share my view, because you don't have to convince me that capacitance is a good tool to use. And I'll share also my opinion on why I think so.
That's excellent, Sven. I think you make a relevant point there, that you're almost agnostic to the manufacturer of capacitance technology, which is again something that our listeners will appreciate. But we are here to talk about the technology in general, and its use. So I think to begin with, just to start off the conversation, Sven, if you can tell us a little more about how you were first introduced to the technology, and how did you come across it, and your initial impressions and the early days, if you will.
And the younger ones that are listening to this will be laughing at me, because although I have gray hair now, there was a time when I was a student, right? So I was a student, and at the time, you hear that from my accent. I'm originally from Germany, and now living in Canada for quite a few years. And actually, I might even say that capacitance is the reason why I moved to Canada.
Right.
Yeah, because what happened was that I did an internship, and I did an internship in Switzerland, and in one of the large pharma companies over there. And it was a group that was producing proteins for internal use. And they were also doing some early process development work. And as I said, by coincidence, one of the projects there that I was able to work on was evaluating a tool for online monitoring using capacitance, online monitoring of cell culture processes. Now, the what was interesting there was that I was able very early on to work with different expression systems, in particular the use of capacitance in further characterizing these expression systems. This was in 2003. So at the time, you know, let's go back into the past. We're only using glass and stainless steel bioreactors
Sure,
process
that's
development. Totally different time. We didn't have these high throughput process development devices available yet. This obviously, through that, capacitance caught my interest. And I was then reaching out to Amin Kamen, who was later on my PhD supervisor, and they had done work in parallel, basically, and really, I thought exciting work, you know, for what I was doing at the time, and it's still exciting work, where they were using capacitance to monitor insect cell cultures, baculovirus expression systems. And you know, when I was reading through the papers, and when you have baculoviruses, they increase in when you have insect cells, they increase in size when they get infected with the baculoviruses, and you can really pick up interesting signals there. So I was reaching out to Amin and basically asking him maybe a year or two later, can I come over and do an internship? And he said yes. And then this led to my PhD, where one of the tools that I continued to use was capacitance. And you mentioned it, viral vectors. I graduated with my PhD in 2010, and the project was process development for lentiviral vectors. Now it wasn't the right time, because at the time gene therapy and cell therapy was far away from where it is now, but already then we were using capacitance to monitor these cultures. So this is some of my
that is fascinating. And we're talking about 2003, so this is, I'm guessing, before the PAT initiative from the FDA.
Yes, yeah, that's
right.
true.
Because to be honest, you know, I think our technology can the capacitance technology can be defined as pre-PAT and post-PAT initiative from the FDA, right? Because our technology, of course, was invented back in 1988. And, you know, we had a little bit of success before that. But the fact that the FDA was saying that your bioreactor cannot be a black box anymore, and you need to, you know, monitor your critical process parameters more strictly, especially those that contribute to your the critical quality parameters of your process. And I think that really got the technology the attention that it deserved. Actually, now that we are talking about the PAT initiative, Sven, initially, and even today, a lot of our customers do convert capacitance to picofarad, capacitance, which is measured in picofarads per centimeter, to offline methods of measurement. It could be cells per milliliter, optical density, dry weight, whatever it is. But we can also increasingly see a number of our customers, such as Biogen and Corteva, they are now more comfortable trusting raw capacitance, and they base all of their control strategies on raw capacitance. And I just wanted to get your perspective on how capacitance used to be perceived in comparison to offline measurements, and where it is today.
Yeah, that's a really good point. I also like what you said about PAT and post PAT. This is interesting because maybe we have a bit of time to talk about this later, because here it's obviously a focus on cell culture processes, because this is where my background is. But I think it's interesting to let people know, and you started doing that through one of the presentations that you gave rather recently, where you connect observations from different fields like microbial fermentation, brewery, yeast, etc.
Yes.
So that's one point I wanted to make. So people are getting more comfortable. That's true. A lot more comfortable, I have to say, because at the beginning, obviously, I got many of these questions. Early on, you said we were one of the maybe early adopters of the technology, and you really had to convince people. First of all, is this reliable, right?
Yes.
And also, okay, that's fine that you can measure whatever it is you're measuring. I'll come to that in a second. But what does that tell you, right? What do I do with that? And then, so the debate around cells per milliliter and cell counts versus capacitance is a good debate. But I think we're now at a point where we're almost beyond that debate. Looking back a bit, when these probes were introduced in the cell culture field, I remember, and this is, again, I'm unbiased and agnostic, but I saw that from a couple of people who were selling these probes, and this is not against anyone. It's just that they were introduced in the market by claiming that what capacitance does is measuring viable cell density. So this was a misunderstanding right from the beginning. There was a very good paper from Genentech 10 years ago, which kind of brought that story to an end, because they did a very, very, I think, elegant and labor-intensive modeling approach, where they were showing that whatever we do, we're not able to correlate capacitance perfectly with viable cell density. So let me just speak about viable cell density for a second, because we're not doing that often enough in cell culture, I think, because we just accept that this is the gold standard on how we characterize our cell cultures. I think it makes sense from a certain perspective, because it's important to know how fast are my cells doubling, right? So doubling time is an important parameter, and it will always be one. Now, counting cells per milliliter, in particular when these cells change in size, is probably not the best approach. There are not exactly many groups who have looked in detail into that, but I can imagine in almost any process, you will see at a certain point in time, you will see that your cells change in size for whatever reason. It could be nutrient limitations, too many nutrients you've added, changes in osmolality. In the case of viral vectors, it could be changes in size, etc. You're not picking this up when you're only counting cells per milliliter. You will pick this up when you measure capacitance. And so, and when you go down to these examples and then show data on processes that you've characterized using capacitance, where you also have good and reliable cell size data, then you realize, oh, maybe it makes sense, and this is what people, I think, have realized over the last couple of years, to use the capacitance value as it comes out of the system, and take it as it is. And you're not always, at least not in all phases of your process, you will continue to look for this almost perfect correlation, because it doesn't mean that the reading is wrong. The reading will remain correct. But it's a complex. It's as elegant as it is early on in a culture, because it perfectly correlates in almost all cases. Viable cell density. As complex it gets later on, because it measures much more than only the membrane enclosed volume fraction, or the biovolume.
Yeah, that's a really good point, Sven. And I know we've discussed it in the past as well. But there are a couple of reasons why capacitance can deviate from the traditional conventional offline cell counts. Let's imagine it's stripe and blue staining technique. As you mentioned correctly, capacitance is, if you want to be really accurate in terms of what capacitance is measuring, it's the viable biovolume of the suspension, and not just the cell density or cell number. And there could be changes in cell size during your process, which are captured in capacitance, but are not captured in cell density, offline cell density. But then there's this entire conversation about the definition of cell deaths, right? So as soon as the cells start dying, then it's such a fascinating discussion, really, because and I would say this is not a philosophical question, it's a biological one. What is death? Because for stripe and blue measurement, a cell is dead when the membrane is so ruptured that the stain enters the cell and colors it blue. And apparently stripe and blue is a relatively large molecule, so the membrane needs to be significantly ruptured. For capacitance measurement, a cell is dead when it cannot hold charge around itself. And for that to happen, the initial hypothesis was that the membrane doesn't need to be all that ruptured. And this was proved by the likes of Mike Butler when he was Professor Butler when he was at the University of Manitoba, where they compared different forms of cell measurement, cell density measurement and discovered that capacitance was actually more sensitive to the onset of apoptosis as compared to trypan blue. And so the hypothesis was that capacitance could reverse apoptosis, or rather, keeping an eye on capacitance, using the capacitance profile could help you reverse apoptosis. And Biogen last year, 2019, they published a paper where they empirically proved this. They induced apoptosis in culture and they measured it using capacitance and trypan blue. And they could, using the information, real-time capacitance information, reverse apoptosis, but could not do that with trypan blue measurement because it only corresponded with mid to late apoptotic stages. So, but having said all of that, Sven, I mean, again, we've discussed this in the past. There is still a good reason why a lot of people want to convert capacitance to cells per milliliter. Maybe their process development work has been done with offline measurements, and capacitance comes in later in the process, and so you cannot just overnight switch your process strategies from offline based methods to picofarads per centimeter. So there's a legitimate reason, and so many of our customers, like you also said earlier, you can get a really good correlation between capacitance and viable cell density. It just depends on which part of the process you're most interested in. So yeah, quite a fascinating topic of conversation, really. So yeah, okay.
Aditya,
Yeah.
Aditya, let me build on that, because I think you brought forward a very interesting example, which is the reversion of apoptosis through online monitoring. Because there's another example which is, in my mind, it's a different example, but I'll explain why to me it goes in the same direction,
Okay.
which is also from Biogen. So someone who's more interested in this really has to Google for An Zhang.
Right. Yes.
And maybe we can put that in the bottom of the screen while I mention it. But no, and seriously, in this group, they've really done excellent work, because this is where we are right now in 2020, right? So we're using the technology not only in process development, but we take it into GMP manufacturing. And in GMP manufacturing, we see and we demonstrate the value of it. So the second example that I wanted to bring forward is the control of feed additions, right? The control of feed additions that they are triggering through capacitance, and they are showing that this leads to a better outcome than when you do it through measuring viable cell density or through other approaches. So this is great, because actually what we've done, let's take a step back. At the beginning, it was, are these measurements reliable? Is that reproducible? What are we getting from it? A feed addition. Yep. And we're saying, hey, something's picked up there. I don't know what it is, but we now are quite certain that what's picked up is changes in intracellular conductivity. But we seem to be able, although it's very complex and different parameters at play in cell culture, as it often is, several parameters change at the same time.
Yeah.
So it makes it complicated, but we can use these signals for process control. And we should, because it's a really good PAT tool.
Yeah, that's again, thank you, Sven. That's a good point, because you mentioned An Zhang and Biogen, and yes, they do. They've devised a strategy to automatically feed the cells based on integrated biocapacitance. And for those interested, can refer to one of their many papers on the subject.